Okay, so Eddie collected three different soil samples, P, Q, and R. He poured the same amount of each soil sample into a funnel which has been plugged with some cotton wool. He then poured 300 ml of water onto the soil sample as shown below. Now, before we do this, we need to understand what soil is all about. All right, now soil is made up of very tiny particles. All right, shown here with the brown stuff. Okay, and there are many types of soil. Okay, and the type of soil depends on the size of the individual particle. Okay, so but for now, I'm going to give you two most common samples or most common type of soil. First of all, what we call sand. Okay, now sand is made up of larger particles as shown here. So if you use a microscope and you look at the grains of sand, you will see that sand is really quite large. Right? All these brown circles represent sand. And because it is quite large, the space in between the sand can also be quite large. And because the space in between the grains of sand is quite large, what would happen is that if there is a drop of water, if there's any water, it can easily pass through, okay, the sand particles and be easily drained. Okay, so that is sand. It is very well drained. It is arid. There's a lot of air in between. Water that drops onto sand is easily brought downwards. Okay, because there's a lot of air spaces that the water can go through rapidly. All right. So this is one kind of soil, and it's called sand. So in science, when we call sand, when we say something is sandy, it means that it is made up of really large particles and the water can pass through easily. Okay. Another type on the other end of this, on the other end of the spectrum, um, we have what we call clay. Now, clay is made up of very small particles, very, very small. It is so small that the space in between it is also very small. And because the space in between is very small, it is harder for the water to pass through. And even when the water passes through, it has to go through a lot of grains, all right, before it can pass through. So clay usually traps water. So it is not like sand. Sand, uh, you know, makes the water pass through easily. That's why it's very well drained. Whereas clay likes to hold on to water, and how it holds on to water is not allowing the water by not allowing the water to pass through easily. Right, and clay is also because the space in between clay is so small. It is also it also does not allow organic matter like dead matter of animals and of decaying plant. It normally traps inside clay. So clay trap things inside because particles find it very hard to move through the very tight air spaces that is found in between clay. Whereas sand does not hold on to things easily, water or anything else, because the air spaces in between is quite large and everything can pass through. Okay. Now, now that we know this, let's look at this. Now we have three soil samples, P, Q, and R, and they collect different amounts of water. When you pour this, so imagine you pour 300 ml for P. Let's say this is soil sample P. When you pour 300 ml, only 110 is collected here after 20 minutes. So where does the 190 ml of water went to? Where did it go to? It's actually trapped within the soil sample. All right. And then for Q, only 60 ml came out. So actually the soil sample held back 240 ml of water. Whereas for soil sample R, 250 ml of water dripped through, and the sample only held 50 ml. So that means this is a very well drained soil sample. That means he has large air spaces in between. That means this is probably more sandy than clay. Whereas for Q, it traps a lot of water inside. That means this is clay. Q is very clayey, and Q actually has very uh, tight air spaces in between its particles that does not allow water to be drained out easily. Alright? Okay, so if you didn't understand what I've just said for the past 5 minutes, uh, rewind the video and make sure you understand that first. Okay, only by understanding those facts can we answer the question here properly, and so that you can have a better understanding of what this question is about. Let's look at the question again. By studying the results, which soil sample P, Q, and R is able to retain the most amount of water? Okay, so the answer is quite easy. Okay, Q is able to retain means hold back the most amount of water. Okay, because water cannot flow through the soil sample Q easily, and the least amount of water was collected in the beaker. Do you see this 60? This 60 translates to the least amount of water. Okay, so this 60 means least amount of water collected. So when you put that, you get the marks. Okay. Next, based on the results recorded in the table, which type of soil is most suitable for a plant that grows in dry, sandy habitat? What did I tell you about sand, right? Sand does not hold onto water easily. So plants that like to grow on dry soil, they do not like soil which can hold back too much water. So the answer for this would be, okay, based on the results recorded, right? The answer would be R. Okay, because plants that grow well in dry and sandy habitat does not need much water. Alright, and soil R traps the least amount of water, therefore making it suitable for that plant to grow. Now, Eddie also observed some air bubbles escaping from the soil, alright, as he was pouring water into the soil. So when you pour water into the soil, air that is at first trapped within the water escape, right? Okay, and they escape in the form of bubbles. Alright, so to explain Eddie's observation, all you have to do is to say that the soil escapes as water occupies the air spaces, alright, in the soil. That's why you can see the water. Okay, so again, like I said, you can only understand these answers here if you have understood my explanation about soil and sand and clay. Then how about P, right? P is in between. Sometimes the soil sample, or most of the time, the soil sample is not all clay or all sand. Sometimes it's a mixture of both. If it has more clay, it will hold back more water, but if it has more sand, it will drain out more water. So again, you need to understand how the spaces in between the particles hold back the water, and how the size of the air spaces also decides on the amount of air that is available in between soil samples. Okay, again, this is a new topic, I believe, for all of you. Do rewind and replay the video again and again so that you can understand. Do not rush to go to the next question, because if you don't understand this one, then there's no point going to the next question. Rewind it again so that you